So today I am going to talk about the consequences of what we call Lorentz transformation. In the early lecture I talked about Lorentz transformation, and there are very important or very interesting consequences of this Lorentz transformation, like length contraction, time dilation, and simultaneity of events. So today's lecture I will be going to talk about the length contraction. So here what I did, I consider two frames of references. Say this is one frame of reference and this is stationary, and S prime frame is moving with v velocity along x-axis, right? And suppose a rod is also placed in the moving frame of reference. So that means when this rod is observed from the S prime frame of reference, in that frame this rod seems to be at rest, right? So that means, so S prime frame moving with velocity v with respect to S frame along x direction, and let a rod AB lie along x prime axis, right? It's lie along x prime axis, and for S prime frame AB seems to be at rest, right? And because rod is also moving with the same velocity with which the frame is moving, right? So that means x2 prime minus x1 prime, as written here, it is the rest length. It is the rest length, means when rod seems to be at rest, right? And in the another frame, S frame, when the rod is observed from this S frame, because S frame is at rest, but it seems that rod is moving with the velocity v, means when observed from so it is a moving length, L is the moving length, right? So means it is from S prime frame as written here, and L is equal to x2 minus x1, it is the length when observed from S frame, right? That's what I have written here in this case. So that means it starts moving with the velocity v1. So that means when I means my objective is to relate these two. So as I know that L0 is equal to x2 prime minus x1 prime, and this x2 prime can be written as gamma x2 minus vt. I will apply the Lorentz transformation here, and minus and it's gamma, it is x1 minus vt. Here gamma is equal to what? Where gamma is 1 over 1 minus b square by c square under the root. This is the length of it, right? So it is gamma x2 minus gamma vt minus gamma x1 plus gamma vt. This will cancel out with it. So it means it will become now that L0 must be equal to gamma x2 minus x1, or it is gamma L, right? Thus L0, let me summarize the result now. That means the result which I am getting is that L0 is equal to gamma L. But as I know that this gamma is equal to 1 over 1 minus b square by c square under the root, and 1 minus b square by c square under the root is always less than 1. That means this gamma is equal to 1 minus b square by c square is always greater than 1. Means if I try to look at this part, then I can say that this L0 is always greater than L. means moving rod shortened. Moving rod shortened. Moving rod seems to be shortened. Seems to be shortened. And this is known as length contraction. This phenomena is known as length contraction. So let me summarize the result here. That what is the meaning of length contraction and what will happen means when the length of a moving rod appears shortened by a factor gamma, or I can say that by a factor 1 over 1 minus p square by c square under the root, and this is known as length contraction. This is known as length contraction, right? So this is very interesting consequence of special theory of relativity. Now in the next lecture I will talk about the simultaneity of events, and then after that I will discuss the another phenomena that what we call as time dilation. So that's all for this lecture.